The next feature we're going to look at is this idea of absolute value. The formal definition of absolute value is the absolute value of A is A if A is greater than or equal to 0, but it's negative A if A is less than 0. So that's the formal definition of absolute value. The way you can think about it is it's a distance, so we're not really worried about plus or minus. It's simply how far away are we from 0 on the number line. That's its absolute value. So it's magnitude only. The direction, whether we're going to the negatives or the positives, we don't care. It's not considered. So some basic results with absolute value then. Well, absolute value of negative x then must also equal the absolute value of x, because they're the same distance from the origin, just one's on the negative side, one's on the positive side. Absolute value of x minus y would give you the same result as y minus x. Because if you like, what you could do is you could factorise out. See, absolute value signs are grouping symbols, just like parentheses. You can still factorise. So you factorise out the absolute value of negative 1, but the absolute value of negative 1 is 1, and so you'd end up with just absolute value of y minus x. The multiplication, you could separate the x and y and find each of the absolute values individually if you wanted to. Same with division. You could do the division all in one hit, or you could find the absolute value first, then do the division. The absolute value of x squared is x squared. Now that one's more interesting. The absolute value of x is actually equal to the square root of x squared. That's kind of important, that one. Because if I was to say to you, hey, I know x is a negative number, what's the square root of x squared? Knowing that x is a negative number. It will be the absolute value of x, yes, but what will that equal? It actually equals negative x. Because x is a negative number. And go back to our original definition, if it's a negative number, the answer is negative a. So the square root of x squared is not necessarily x. If x is negative, it would be negative x. Absolute value of negative 5, nice easy one there to start off with. Oh, 5, what do you know? As I said, it's just a grouping symbol. So you do whatever's inside the grouping symbol first. 6 minus 8 minus 2 is negative 4. We end up with 4. Once again, grouping symbol. Order of operations, we do the inside first. 6 3 is 18 minus 20, we get negative 2. Absolute value of negative 2 is 2, so 7 minus 2 is 5. Just like with algebra, we don't need to write the multiplication sign there because it is a grouping symbol. So 3 times the absolute value of negative 6 is just 3 6s, 18. And this is what I was just talking about. The square root of x squared, if x is less than 0, we now should all know that answer. Negative x. Negative x. Right, absolute value graphs. Let's just think of linear functions to start off with. So if y is the absolute value of mx plus b, so some straight line. Okay. Basically, whatever's below the x-axis bounces, so it reflects. It's sort of like you're snapping it and turning it up, and that's why you get a sharp point. It's like you've got to imagine, I've snapped the line and I've bounced it up, so you end up with a sharp point there. So the most basic one, I guess, is y equals the absolute value of x. And you get the classic V shape of an absolute value graph there. So you imagine we had the line y equals x, and we got that bottom bit, we snapped it and went, right, let's flick it to the top, put it above the x-axis. When we draw these sorts of graphs, it's usually good to label a couple of points in to give it some sense of scale. So 1, 1, minus 1, 1. So if I had to sketch the absolute value of x plus 2 then, I could say, well, I know my basic curve is y equals the absolute value of x. What have I done to it? And this comes back to the shifting or the translating idea. The absolute value is the grouping symbol, so it's grouped with the x. So I can say, well, I've shifted it left 2 units. So move it 2 units, there's our graph. And label a couple of points on it just to, as I say, give it some sense of scale. Of course, I could have done it another way. I could have said, well, look, I'm actually going to start with the line y equals x plus 2. But then I'm going to snap off what's ever below and reflect it above. So we get the same picture. It just depends how you think about it. What about this one then? Instead of being absolute value of x plus 2, just the absolute value of x plus 2. I could say, well, I've got the basic shape, the absolute value graph, but this time it's a vertical shift. We're going to shift that up 2. So up 2 it goes. There's our graph. Solving absolute value equations. Now, it's really tempting just to look at this, and maybe you would do it this way, I don't know. You'd look at this and just go, oh, x is plus or minus 7. Absolute value of 2x minus 3 is equal to 7 then. We'd say, well, 2x minus 3 equals 7. Aha! Here's where the difference comes in. I would not say 2x minus 3 is negative 7. I'm actually saying the negative of 2x minus 3 is 7. And it all goes back to the definition of absolute value. Okay? So the absolute value of 2x minus 3 is either 2x minus 3 or the negative of 2x minus 3. Now obviously you get the same answer, but it's just how we think about it. And we think about it using the formal definition. So solve the left-hand one, we get x equals 5. The right-hand one, we get x equals negative 2. We don't leave our answer like that. That's just two separate equations we've solved. We then write a conclusion down and say, oh, well, therefore, x is either negative 2 or it's equal to 5 as well. Absolute value of 2x plus 6 is 3x minus 1. So again, I'll say either 2x plus 6 is 3x minus 1, or the negative of 2x plus 6 is 3x minus 1. So left-hand side, solve that, get x equals 7. Right-hand, solve that, x equals negative 1. This is where we have to be real careful, because the big mistake people make is not to listen to what their year 7 teacher told them. And that is, whenever you're solving equations, check your answer, see if it works. X equals negative 1 doesn't work. Sum it back in. Left-hand side, absolute value of, well, it'd be negative 2 plus 6, so absolute value of 4. Right-hand side, sub it in, negative 3 minus 1 is negative 4. So we're saying the absolute value of 4 is negative 4. Well, that's not correct. So that one is not a solution. Why does it happen? The reason it happens is what we've actually done to solve this, we're saying, hey, this equation is too hard to solve. I'm going to change the question into these two other ones. Now, sometimes when you do that, you create new solutions. You will find all the ones you want, but occasionally you'll create extra solutions that don't actually exist. And that's why you check. If you think about it, the only way it's going to happen is when we have algebra on the right-hand side. If it's a constant like 7, I'm never going to have a problem, because I'm never going to get absolute value equals a negative number there. The only time I could get a negative number is if I'm changing the value of x. So they're the ones we really have to be careful with and make sure we check. So this one, x equals 7, only solution. Okay, there we go. That's a put it.